Now, we can define also instantaneous velocity. So, in instantaneous velocity, you can similarly, that is the velocity at any particular instant is known as instantaneous velocity. We can write first like average velocity. Average velocity V is equal to, we can write delta x upon delta t, that is the total displacement divided by a total time interval, and we can write here V is equal to limit delta t tends to 0, then delta x upon this delta t is equal to dx upon dt. So, derivative of displacement with the time dt with the time is known as instantaneous velocity. But take care here, in this case here, instantaneous speed is equal to magnitude of instantaneous velocity. So, instantaneous speed is equal to magnitude of instantaneous velocity, but you cannot write same thing with this one. The average speed is does not equal to average velocity. So, take care while doing this. So, now you have done here uniform speed and instantaneous speed, uniform velocity, instantaneous velocity. Similarly, if the speed and velocity are changing with the time, suppose the body is traveling equal distances in unequal interval of time. If the distance is unequal in equal intervals of time, then we can call it a variable speed. If the body is covering equal displacements in unequal intervals of time, then we can say body is having variable velocity. But see here, in variable velocity, there is change in magnitude or direction or both. It means only magnitude is changing, then also the velocity is changing. If direction is changing, also velocity is changing. If both are changing, also velocity is changing, because velocity is a vector quantity. So, we have to take care of the direction, but in speed it does not make any difference. So, now these are about all these basic terminology or the basic concepts of the speeds and velocities. Now, we will come back to the uniform motion in a straight line.